For this question on plane geometry, I think this question is very generous. So overall, it's a 9 marks plane geometry, but it's very generous. So for example, the first part simply wants you to prove similar triangle. So if you go to the logic of similar triangle, there's only like you will need to try to find same angle. And in this question here, right, if you have colored out the triangle, you already can see there is a common angle. You can see that A is actually the common angle for you to prove similar triangle. Okay, and then the next one, some students couldn't see where is the next angle. So essentially the next angle come from the tangent. So they already said that there is a tangent. So if there's a tangent, you should have looked out for tangent chord theorem. So this tangent actually make an angle here. So in the blue triangle, we got this angle, and this angle, by the idea of tangent chord theorem, will be equal to this. So that is actually your second angle. So in the blue triangle, you can see that this angle is made by tangent chord. So ABF is actually the same as ABF is actually the same as ADB. That is in the red triangle. So this is the tangent chord theorem. So with the two angle, then that is already sufficient for you to prove similar triangle, and that's it. So it's 4 marks, but essentially it's just the two angle. That's all. Okay. So that is just the first part. Okay, the next one, the next part, they gave you one piece of information. A circle can be drawn through BCX with BC as a diameter. So they just gave you this particular one. So you make sure you can diagnose what are they trying to give to you. So BCX can form a circle with BC as a diameter. So BC is the diameter. And you can actually draw a circle like this. So what's the purpose of giving you this? Okay, at least for the time being, right, you should be able to see that there is a 90-degree because BC is the diameter. So BXC is actually equal to 90-degree. Okay, so with the information here, you can realize that BXC is 90-degree because it's angles in semicircle. So that should be what you have infer first. Okay, and then my whole idea is to decide the type of quadrilateral for EBFC. So, and we need the reason to support. So where is EBFC? So if you want to, you can erase out everything. Okay, but do bear in mind that we already got a 90-degree here. Okay, so EBFC. EBFC. So you need to decide what is this shape. So it's a four-sided figure. The thing that should come to your mind will be is there any parallel line? Because if there is a parallel line, so if it's a four-sided and there's a pair of parallel line, then we can just conclude it as a trapezium. So the critical thing will be, is there a pair of parallel lines or not? So it will narrow down to looking for parallel line. Okay, so EBFC, what shape is this? So the shape is dependent on whether there is parallel line or not. So you need to look for it. So just now they already gave you information that BC is diameter. Because BC is diameter, we already gotten BXC is 90 degree because of the property angles in semicircle. So is there anything else that can lead you to decide some parallel lines? Okay, so if you look carefully, the circle, right, initially, right, we started off with FD. So FD is also a diameter. And because FD is also a diameter, we also have a 90 degree. We also have a 90 degree, which is here. So DBF is 90 degrees. Same reason, is angle in a semicircle. So these two 90 degree actually help us to form the interior angle. Do you realize? So it actually forms the interior angle. So by the converse of interior angle, these two will be parallel. So we can conclude that in the quadrilateral EBFC, BF is parallel to XC. So with this being parallel, the whole four-sided figure actually becomes a trapezium. Okay, that's all. Okay. So the shape is dependent on whether there's parallel line. So you got to look out for information that can prove parallel line. And because they gave you diameter, you need to pick the info from there. Okay, I do the phrasing in my worked out answer. So you need to write up by the converse of interior angle, then what is the conclusion on parallel line? From the conclusion of parallel line, then you decide the shape. Okay, so I think this one is quite a generous question. You don't need a lot. You just need to see the flow of it, and it's like you just get 5 marks, 4 marks for it.